It seems everywhere you look today, there's always something about a new problem with our climate, whether it's global warming or an ice age. Yes, actually, people believe now we could be going into an ice age in 2030. That's only about 15 years away. The reason why isn't found in weather forecast or your grandpa's funny bone, but science has proven that through a complex series of events occurring all the way from the sun, we may be in for a cold future. In order to get some idea about how this works, first you'll need to answer a very puzzling question. How does the sun affect our climate? Well, it took dozens of scientists at one workshop all working together on this because, get this, not one scientist has the knowledge to figure this out. And then even with the dozens of scientists that were there, we're still only scraping the surface of this subject. What we do know is there is a sun cycle.
This picture shows the sun going through its different cycles. You'll notice the brighter ones are when the sun's at solar maximum, and the darker ones are when it's at solar minimum. Solar minimum means the sun has more sunspots, and the sunspots decrease its luminosity. Here's a view of the sunspots from Earth. Each of those little dots are actually larger than Earth itself. The process depicted here takes about 11 years to get from solar maximum back around to solar maximum. So what about the sun changes in these 11 years? Now let's say we have Mr. Perfect Sun. Mr. Perfect Sun doesn't change, but shines the same brightness and gives off the same amount of ultraviolet rays and energy particles all the time. He operates at 100%. Now let's say we have Mr. Spotty Sun like our sun. Mr. Spotty Sun is very insecure and changed a lot of things about himself. But in 11 years, you know he'll always come back and be the same guy. One thing Mr. Spotty Sun is never pleased with is his luminosity, or how bright he is. Sometimes he'll be at 100% luminosity, like Mr. Perfect Sun. But halfway through his insecurity cycle, he'll be a little shyer and give off 99.9%. That seems small, but that 0.01% is more energy than the entire world produces in all of its radioactive decay. Who's insecure now? Mr. Spotty Sun has a bit of a temper when he is not as luminous as he used to be. The spots that reduce the luminosity are huge contributors to the constant barrage of extreme ultraviolet rays constantly hitting the atmosphere. The more spots, the more EUV. Over the cycle, the EUV actually varies by a factor of 10 or more. On Mr. Earth, there is a layer in the stratosphere called the ozone layer, which, as you may know, has the job of blocking most UV from giving us the worst sunburns you ever saw. The reaction between the ozone and the UV actually produces heat. The dimmer the sun is, the more UV comes at us and the hotter the atmosphere gets.
What happens down here on Earth is way more complicated. Figuring that out was the goal of the scientists who all met together and ended up writing a 54-page book called The Effects of Solar Variability on the Earth's Climate. Now, what does this mean for an ice age? We need to now turn to the concept of the sun's magnetic field. Unlike the Earth's magnetic field, the sun is constantly flipping from North Pole to South Pole and back, and each of these flips actually occurs every 11 years. Dr. Zarkanova wrote an article for the Royal Astronomical Society on the subject of the impending ice age. Her research measured two different layers of the sun, each with a frequency of their polarity change about 11 years, but their difference was enough that they were offset in time. Think about these different frequencies as two different waves. So when the waves are perfectly aligned, this is a solar maximum, and that's when the sun is at its has its most sunspots and is giving off the most UV. Now let's say these are exactly the opposite. When they're exactly the opposite, they almost cancel each other out, and that's when there's about no sunspots, and that's solar minimum. So we should see some sort of solar minimum sometime in history, right? Well, we do. It was the year 1645, and it was very cold. People were walking across rivers. This period was dubbed the Maunder Minimum and became the first recorded mini ice age. Of course, now you're probably wondering, wait a minute, was there even global warming in 1645? What about global warming now? Isn't that going to have a big impact on our little ice age? Glad you asked. Some theorists think that global warming will actually cancel out that incoming ice age and we'll be just fine. So, hey, why worry about global warming anymore?